In this video, we're going to talk about displacement in more detail. Now that we understand how to define position, we can talk about a change in position, which we call displacement. The symbol for change is the Greek letter delta, and it's the triangle. So delta x means the change in x, or the change in position. Displacement describes how far you are from where you started, regardless of how you got there. So we're really talking about starting from one position and moving to another, and then finding the difference between those two. For instance, if you drive 60 miles from Pennsylvania to New Jersey, and here you can see that we're starting at x naught, and I'm going to put a little vector sign on that. And we're going to some position x. Okay. And then if we go 20 miles backwards, or back towards Pennsylvania, so here's where we had x. Here is now where we have x final, and we're going to label that x final. Then what we can see is that we've traveled a distance of 80 miles, but we have a displacement of 40 miles. Okay? Since that is how far we are from our starting point here, or the reference point. And notice that the displacement is the purple vector. Measurements of distance can only be positive values, or magnitude, since it's impossible to travel a negative distance. However, displacement can be positive, or it can be negative, since it can end up, or since you can end up either to the right of the reference frame, or the reference point, or the left of the reference point. So if we start here and end here, notice that the displacement is positive. If we start here and end here, notice that the displacement is negative. Scalar quantities, as you remember from our first lecture, is a quantity that has only magnitude, or a number value. Vector quantities have both magnitude and direction. So which of the following quantities are vectors and which are scalars? Go ahead and pause the video now and make your selections. Okay, so let's go ahead and mark it off. For time, it is a scalar quantity. Distance is scalar. Displacement is a vector quantity. And speed is a scalar quantity. How far your ending point is from your starting point is known as Okay, let's see if you have the right answer. B, the displacement. A car travels 60 meters to the right and then 30 meters to the left. What distance has the car traveled? Go ahead and pause the video now and solve this problem. Okay, so let's see if you have the correct answer. The total distance is going to be the distance that you travel first plus the second leg of the distance, and that's going to be 60 plus 30, and that gives us 90 meters. Don't forget, you may have said, wait a minute, why isn't it 30 to the right? Well, that would be your displacement. Okay, so now if you travel 60 meters to the right and then 30 to the left, what is the magnitude and direction of your displacement? Okay, so let's see if you have the correct answer. It should be 30 meters to the right. And I'm going to go ahead and put the vector sign here, and I'm going to put the I hat direction here. Starting from the origin, a car travels 4 kilometers east and then 7 kilometers west. What is the net displacement from the original point? Pause the video now to solve this problem. Okay, so let's take a look at the solution. The answer is A. Does everyone see why you got A for the answer? If not, you might want to go ahead and make a note, and then I'll get back to you on this one. But keep in mind that you're going east and then west. You run around a 400-meter track. At the end of your run, what is the distance that you have traveled? Go ahead and pause the video now if you need to. Okay, so let's take a look at the answer. The answer is 400 meters. You run around a 400-meter track. At the end of your run, what is your displacement? Go ahead and pause the video if you need to. Okay, so let's take a look at the answer. Your total displacement is going to be 0 meters. I'm going to add a direction because I'm adding the vector sign here. It is a vector quantity. Okay, in the next video, we're going to talk about average velocity.